GeoSierra has made this short video to explain how the Bolan Hodder shales cannot be commercially enhanced by current hydraulic fracturing technology. At the Preston New Road site, there are extensive slick-and-slide bedding planes throughout the Bolan Hodder shale formation. The bedding planes are near horizontal, dipping at around 20 degrees towards the west. The slick-and-sided bedding planes are smooth, highly polished, and have extremely low angle of friction of around 6 degrees. A hydraulic-induced vertical fracture will propagate both horizontally and vertically until it intersects a slick-and-sided bedding plane. Due to the extremely low frictional properties of the slick-and-side bedding planes, shear stresses can't be transferred through it and tension can't be induced in a shale above it, so the frac can't grow vertically anymore. At this stage, the injections should stop. If the injections are continued, the frac will balloon, and on further increase in bottom hole pressure exceeding the overburden, the open bedding planes will now become a highly permeable conduit for frac fluids to flow. In fact, the permeability of these bedding planes is aperture cubed. This phenomena has been known since the late 70s from mine-back experiments conducted at Nevada test site. In 2018, Cadrilla injected at excessive pressures far exceeding the overburden. Initially, they first created a vertical hydraulic fracture. It intersected a bedding plane, then opened the bedding plane and extended almost a kilometre to the east, because these open bedding planes are highly permeable conduit and the frac fluids can flow kilometres from the injection point. In 2018, the bottom hole injection pressures exceeded 800 bar when the overburden was only 530 bar. A reckless action, and maximizes the likelihood of induced seismicity by allowing frac fluids to propagate considerable distances, in this case up dip towards the east, to seek out a highly stressed fault. In 2019, the UK regulatory agencies were warned that if they didn't impose bottom hole pressure limits or have tilt meter monitoring, the induced seismicity risks would still be apparent. Now in 2019, the same procedure was repeated. You'll see where the injection sleeves are, and the induced seismicity is all towards the east because the frac fluids have been allowed to migrate along open bedding planes due to the excessive bottom hole pressures during the hydraulic fracturing. So in other words, they haven't fracture enhanced the shales for gas production. What they've done is injected fluids into the subsurface at high pressure, lifting the overburden, opening near horizontal bedding planes, and allowing those frac fluids to migrate considerable distances, in this case over 800 meters, towards the east, up dip on these open, highly stress sensitive bedding planes. Now let's recap. A vertical hydraulic fracture is created. It grows and intersects a slick-and-slide bedding plane. Bottom hole pressures rise. Above overburden, open the slick-and-slide bedding plane, which is a highly permeable conduit for the frac fluids to migrate kilometres from the injection point. These frac fluids have migrated 800 metres up dip from the injection point, maximising the likelihood of induced seismicity. At Preston New Road, they have heightened the risk of induced seismicity by the excessive injection pressures opening bedding planes for minimal gas enhancement. Thank you for your attention.